Hello and welcome to another episode of Carbohydrate Discussion Series. Today, Deepak will present Dissecting the Influence of Oxazolidinones and Cyclic Carbonates in Sialic Acid Chemistry. Let's begin the session.
Good morning, everyone. Today we'll be discussing this paper from Chem that is entitled as Dissecting the Influence of Oxazolidinones and Cyclic Carbonate in Sialic Acid Chemistry. So in this work, they have discussed about the role of the cyclic protecting groups in the stereoselectivity. So as we know that, protecting groups are important in carbohydrate chemistry. Most of the time they can be used as a protecting group to block the hydroxyl groups to tune the reactivity or to modulate the reactivity, and in some of the cases these protecting group itself are involved in the stereodirecting effect in the glycosylation. So when we talk about this cyclic protecting group, in case of pyranose, as in case of this glucosamine derivative, it is known to give the alpha selective product when this C2N and C3O is protected with this cyclic protecting group. It is known to give the alpha selective product. So similarly, utilizing this concept to stabilize to get the alpha selective product, and it is known fact that it help in the and it increase the anomeric effect when these kind of protecting groups were used. So similar concept has been used in sialic acid also. So in sialic acid, it is already known that when this C4 oxygen and C5 nitrogen is protected with the cyclic protecting group, it is known to give the alpha selective O glycoside or C glycoside or thioglycoside also. So these kinds of reports were there earlier, but till long time it was not known that how actually these groups were affecting the selectivity. So people were always interested what is the mechanism involved in this stereoselective process of cyclic oxazolidine protecting group. So to investigate that, they have taken this challenge. So in this work, they have decided to investigate the role of the cyclic protecting groups towards the alpha selectivity. So to begin with, they thought to start with the study the mutarotation, how this mutarotation is happening in this kind of molecule. Suppose we'll take this lactol. So already it is known that the moment these cyclic protecting groups were there, most of the time when it will go for mutarotation, if it will left in the acidic solution, it will stay in the open chain keto form. So it was very difficult to study this mutarotation in silosyl hemiacetal because most of the time it will remain in the open chain keto form. So to to overcome that, what these authors have decided, they thought to go for the radical intermediate. So in that case, if they will able to generate this radical, and then in the presence of tempo, they will make this kind of intermediate, and then since this radical generated from tempo is the persistent radical, so it won't couple with the sialic acid radical, so it will form always heteroglycoside hetero product, not it will go and undergo heterocoupling, not the homocoupling, like it won't be quenched with the self coupling. So that's why it is the persistent radical. So to begin with, they have taken this xanthate modified psilocides. So they have kept it in tempo, and in the presence of photolytic condition, they have formed this tempo psilocide, which is forming mostly the like beta more, alpha is less product. So when they have kept this static material itself, so their main goal is to study the anomerization. So they thought, okay, leave this for if they will keep this product further in the presence of light, whether any change is there. So they have observed that there is no change in the anomeric ratio of this product if they are keeping it for the longer time in the presence of light. So to see that whether any effect is there on the donor itself. So if they are keeping donor itself in light, so in that case, after some time they are observing the elimination product, but there is no change in the anomeric ratio of alpha beta. So they have synthesized various derivative of this tempo like coupled psilocybin. So in this case, in some of the cases, they have kept this NHAC and diacetyl protected, then this cyclic protecting group, and further with this acetyl protected cyclic protecting group. So to begin that, they have taken this corresponding psilocybin containing this tempo attached psilocybin, and they are keeping that solution and they are heating it at 90 degrees Celsius in this uh, Cl2 CD4 with the periodic monitoring by NMR spectroscopy, and they are waiting till the equilibrium is attained. So in all these cases, they have observed like when like these compounds has been treated in this CD2Cl2, and in these cases what they have observed that in the moment this oxazolidine protecting group is there, in that case alpha to beta ratio is maximum. So in that case alpha is maximum in this case, and in the moment still protecting group is there, it is reducing a little bit, and the moment there is no this cyclic protecting group is there, alpha to beta selectivity ratio is comparatively less. So the initial thought it could anyone can think of it like presume of about the selectivity is that it maybe it is because of the hysterics effect, like this radical tempo radical when it is getting coupling here because of this 1,3 diaxial interactions will be there, 1,4 di proton interactions will be there. Like if you'll see here, the proton present here and then at this C6 position, because of that, because of the hysteric reading, this radical will come from the equatorial position. That could be the reason. But the moment if we try to make this OMe glycoside, in that case, they are getting the beta selective product if methyl glycoside is there in this particular cases. So it was the obvious reason. But in the case, if they are leaving it for the anomerization, then also they are getting alpha only, not beta product. So from there, it is thought that that may not be the reason. Hysterics are only not involved. There could be something else. So what they are proposing? They are proposing that the dipole moment of this open chain and cyclic carbonyl functionalities in nonpolar solvents are very significant role in the selectivity. So as they are showing here, this cyclic protecting group has the maximum dipole moment of 5.07, and when it is getting substituted with a steel protecting group, the dipole moment is reducing. Similarly, in the other cases also. So it is correlating with the previous observation that the moment this cyclic protecting group is there without acetate protection. So in this case, dipole moment is maximum. So in that case, they are getting the maximum selectivity. Similarly, when here the in this case dipole moment will be little moderated. So in that case, selectivity is little less, and similarly in these cases. So if you'll see the orientation of dipole moment, so what they are showing that the because of the dipole moment of this oxazolidine non-ring, so it is reducing the electron density here, and that's how indirectly it will means help modify the mechanism of the reaction. It will go with the associated mechanism instead of the SN1 kind of reaction. So in this case, the dipole is completely parallel to this C4O4 plane, and so that's why in this case it is maximum. But the moment this still substitution is there, in that case it is getting little bit reduced, but still the resultant will be in this direction. But if we'll take this either diacetate or N-acetyl substitution, in most it is known that it will be the in this parallel configuration, anti-parallel fashion. So it will cancel out the resultant dipole moment and it will be very less. To see the further role of this, what they have done, they have taken this thioglycoside, keeping this cyclic protecting group, and in one case this normal NHAC protecting group is there, and they are taking this allyl allyl tin tributyl and then hexabutyl tin they are taking, and they are irradiating with the light in the presence of toluene at room temperature. And what they are observing, they are getting 1:1 selective products. But in the case of when they are taking chloride donor, again it is forming 1:1 selectivity is there. So from there they are showing the, like from this result it is shown that the lack of influence of this cyclic protecting group on the kinetic selectivity. Since these reactions are these products are kinetic, so in the case of kinetic product, the selectivity is not there because of this cyclic ring. So there could be the possibility the intermediates are forming like this carbocation or radical. These are mostly in the planar form. So that's why there is not much role of this cyclic protecting group. So in this cases, if we'll see the another possibility how these products could form in 1:1 mixture. So most likely the actual intermediate involved in the reactions are these half chair conformations. So in this case, none of the product is none of the phase is specifically blocked from the any one side. So both attack from the beta phase and alpha phase are equally favorable. So that could be the reason they are getting the 1:1 mixture of the alpha beta ratio. So what they have thought to show this role of this cyclic protecting group, they will use their concept of fragmentation, and using this mass fragmentation technique, they will show the role of these cyclic protecting groups. So what they have done, since it was observed previously that in the case of thiodonors, if it will go undergo this mass spectral fragmentation, the first fragmentation will begin from the state group in present instead of this anomeric carbon to oxygen cleavage. So that's why they have made this phosphate donor. So they have synthesized this various phosphate donor containing this either cyclic, acyclic protecting groups. So what they have observed in the case like, so the pathways involved in the fragmentations could be, so in this case they are observing this uh, carbocation intermediate with sodium and then this anion forming phosphate anion intermediate. So these two they are observing. Another possibility could be either this phosphate anion and then this elimination product also they can observe in mass fragmentation. So in this when they are, so they have started with the certain voltage. So initially they have irradiated with 40 40 volt. So in that case there is no fragmentation they are observing. So that cone voltage they are increasing. As we know, the moment this cone voltage will increase, so this fragmentation pattern will change. So initially when they are irradiating with 40 volt of cone voltage, in that case they are observing the M plus Na peak, but there is no fragmentation. So then they are gradually increasing, and what they are observing in the case of this cyclic protecting group containing both OH, no nitrogen is there. In that case, they the maximum fragmentation voltage of 95 is there. In that case, they will be observing this cation and then this anion as an M plus Na. And similarly, when they are moving from this cyclic carbonate group to an oxazolidone protecting group. In that case, it is little lesser, and the moment this will be substituted with acetate, again it will be 83 volt. And similarly, in the case of this diacetate or NHACAC, still protecting group, it will be list. So from here, they are concluding that since like because of this, it will have the maximum dipole moment, so that's why it is reducing the positive electron density at the anomeric carbon, and because of that only it will need the maximum voltage for fragmentation. So it is clearly showing the significance of dipole moment. The moment in the cases where dipole moment is maximum, so that their fragmentation cone voltage required is the maximum thing. So that's how, and indirectly they are showing that the moment this cyclic protecting groups are involving, so it will do, it has the two consequences. One is that, as we have discussed initially, so these equatorial glycosides are stabilized with respect to the monocyclic system by the diminishing the propensity of pyrenosyl ring oxygen atom to donate the electron density into the sigma orbital. Like if you'll see this, because of this lesser lesser charge here, so its tendency to donate the electron density to the sigma star orbital of this beta glycoside will be very less. So it will like kind of, it automatically it will stabilize the equatorial product, that will be the thermodynamic product. And second thing, because of this cyclic protecting group, the stereodirecting group or influence, it is getting increased indirectly again because of the destabilization of the oxycarbenium ion. That's why that like indirectly it will the intermediate, as we discussed, then the intermediates involved will be like it will be kind of associated intermediate, not the dissociative intermediate. So whatever as we generally know, the most of the time this triflate or whatever, in this case phosphate, or in case of thio, some this sulfonium intermediates will form. So those will be like in beta configuration mostly. So because of this destabilize, like lesser positive charge, so it will undergo kind of concerted SN2 kind of mechanism, not specifically SN2, but it will be either SN2 or it will be towards associative mechanism. So eventually it leads to the formation of the alpha selective product. So these are their main conclusions. So one was that it will destabilize this beta intermediate by giving the less of electron density to the sigma star orbital of beta glycoside. And another explanation is that it will undergo either associative mechanism or similar to SN2 kind of mechanism in the intermediates, because of the depending on the dipole moment of this cyclic protecting groups. Thank you.
Hello.
Yes.
Nice presentation. Go to number slide 5. So how this this reagents they're telling is the kinetic reaction is
So I think it is already known when they are forming this kind of C glycoside. So in this case of radical C glycoside, they
okay.
have shown that. I also didn't understood it much. So in the different donors, in the case of
Uh,
thioglycoside and chloride, in both cases they are getting 1:1 product only. And it was
okay.
already known that these kind of products are like kinetic products, because these
Mm-hmm.
radicals are not this
Stable.
persistent, means persistent as tempo. Tempo is a
Okay.
persistent radical, means it will stay as it is, it won't quench by itself. But
Mm-hmm.
in case of these kind of radicals, I guess, these so if product has to form, it has to form immediately. Otherwise, it will
Okay.
go under polymerization or self-coupling. So these
Okay.
are the different than tempo. But in the other case, like if you'll see in this case, they are able to do enumerization and they are
Hmm.
getting the thermodynamic product because they are using this persistent radical effect, which is that it will wait for like two couple. It won't go under
Okay.
self-coupling. Either it will give heterocoupling only,
Hmm.
otherwise it will stay as it is.
Okay.
So in
Okay.
this case, so so whenever they are getting this kinetic product, in case of kinetic product, there is
Hmm.
no selectivity.
Okay. Yes. Yes. Yes.
So
Yes.
because of that, they are correlating in that case. It could be because of it is similar to the this hexacarbenium ion. And in
Hmm.
that cases, the intermediates involved are like in the particular donors they are taking. In that
Okay.
case, they are able to get the 1:1. So all these are like they are trying to explain why that is happening. So to
Okay.
give the better explanation, they have taken this phosphate donor.
Hmm.
So
Hmm.
that
Hmm. Hmm.
in that
Yes.
case they are able to show. So these are the models. It's not like actually
Hmm.
that is happening because in the case of thioglycoside itself, you are
Okay.
keeping this donor and you are getting the alpha selective product, right?
Yes. Yes. Yes.
But in actual reaction, when they are trying to show the mechanism, so
Hmm.
those are may not be the suitable models to
Uh-huh.
study using this particular experiment in the case of
And
radical.
I don't know what exactly the reason. Everywhere the people uses phosphate donor only instead of thyroid donor because the phosphate donor gives better selectivity than the thyroid donor.
So
And it
selectivity
is.
also, and in this
Hmm.
case, they have explained that like
Hmm.
this is completely voltage driven phenomena like fragmentation air discussion. I also
Okay.
don't know, but they are
Hmm.
mentioning that in case of thio, the
Hmm.
fragmentation pattern is different. Like other protecting group will start
Uh-huh. Yes.
fragment
Yes.
first
Yes. Yes.
acetate will go
Uh,
before the xenomeric cleavage.
uh,
So that's why they have
uh,
taken this first.
here to study and all is fine. Even to prepare any of the silicide also. At present, the best way to prepare is the alpha is the phosphate donor only.
Correct. So
At present,
maybe
thyroid donor we use because convenient to handle. But otherwise, if you see any of the paper, they'll use phosphate donor only to prepare the at least when there are these biological studies they want to prepare. That time they use phosphate donor.
so already few reports are there. So what they have
Mm.
cited in this paper, there is some another group has done similar studies. So
Uh,
what they have observed that in the case of thioglycoside, the
mm.
acetoxy group will undergo in primary fragmentation. Like the
Okay.
protecting group will leave first,
Uh,
and then this other this anomeric carbon
okay. Okay. Okay.
sulfur
Okay.
bond will cleave.
This is
But
very much fine. For your mass spectral analysis, that is very much what is that understandable. Okay, this is what this is very doing. Just I'm generally telling for the alpha selectivity.
yeah, correct. So maybe
Uh,
indirectly these roles will be also there. But I
okay,
think
okay,
because
okay,
of the
okay.
synthesis and other perspective, people are
Uh,
preferring thioglycosides because that is easier to handle and make also.
that's true. That's true. And also, if you see compared to the N-cetyl, NH at what is that 5 6 carbon, they are telling they are getting more alpha selectivity.
This case,
No, not that case. The 16 and 17
yes. So again, they are explaining using this dipole moment
dipole
itself.
moment.
Yes.
Uh,
So the moment this acetate is coming, it will reducing the effective dipole moment a bit. So
Okay.
ultimately, if you will compare just the protecting groups, so what they are showing, this is the maximum when both are oxygen. That you know
Okay.
in the KDN, this ketodeoxyglycerogalactosa,
Okay.
mean that is H
Uh,
oxygen derivative. So this will give automatically in this kind of system, this will give maximum selectivity. So already this is known in others of the paper, they have shown this kind of derivative also.
okay. Fine. Fine. Fine.
So this will give the maximum alpha selectivity. So here they are showing that is indirectly because of the dipole moment
Dipole
only.
moment.
Yes.
And in that case, more dipole moment, then the more selectivity.
Yes.
But NH should have a less dipole moment, right? Because that is acting away from the oxazolidinone carbonyl group. If you see the previous slide,
Yes, sir.
this one, if you see,
Yes. What you are saying?
it is acting again is opposite to the carbonyl group dipole moment, right? In that case, it should reduce the effective dipole moment, no?
So
Or
this
maybe
case,
for convenience, they have shown like that. Yes, yes. Six
no,
only,
no.
entry six.
It is reducing, right? In this case, they will observe the maximum.
Okay.
The moment this group is substituted with
Okay, okay, okay,
acetyl,
okay. Okay. That's why if I have more, that's why 5 is more selectivity than 6. Yes,
yes. So
yes,
that's
yes,
why,
yes.
like, if you will see in
Mm,
general cases, we are using this protecting group, not AC
yes,
substituted.
yes, 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 yes. No, no, no.
So,
Yes, 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 yes.
so
I have
and
used 6 only, but 5 can be used, I
yes,
guess.
so like if you'll see here, the anomeric ratio they are saying this is also good. So it is
Uh,
giving good selectivity,
yes, yes,
but
yes,
this is
yes.
the maximum. So this is just anomeric ratio in the case of
Mm,
radicals reaction.
mm,
So
mm,
radical anomerization. So
mm,
why radical anomerization? Again, like actual reaction is happening something different. Like this reaction is if you will see. So this is kind of ionic reactions that is
mm,
most likely it is going underway the normal reactions we do. But to explain that, so when they
mm,
are
mm,
coming
mm,
to this hemiacetal, that is the obvious choice. We'll take
mm,
hemiacetal and we'll see the
mm,
mutarotation.
mm,
But in the
mm,
case
mm,
of sialic acid, already all these
mm.
things has been reported very early. So in
Earlier,
this case,
yes.
it is difficult to obtain
Mm.
this. Like keeping this
Okay, okay, okay.
cyclic and keeping hemiacetal, the moment you will put into the solvent, it will
It will
go
go.
undergo this
Mm,
open chain form and it will stay in keto form. That
mm, mm.
also, this study has been done. So because of the strain it is generating, because of the
Okay.
strain, this ring is not
Hydrolysis.
sustaining. So that ring is liable. So what they are writing in the old references are that because
Uh,
of the liability of this molecule, there we cannot undertake this for the investigation. So what they
mm-hmm,
have done?
mm-hmm,
So
mm.
another experiment they have done, they have tried to do the glycosylation with the corresponding ol, tempol. So in
Okay,
that
okay.
case, like you take this OH and do
Mm,
the glycosylation here the way you are doing. In that case, they are not getting the this psilocybin. So that's
mm.
why then they have decided to go with the radical.
Right, right.
And same, the another important highlighting point is that this persistent radical effect.
Mm-hmm.
So that they
Yes.
are bringing here. So that is giving time already. It is known that
Mm,
this
mm,
corresponding radical of sialic acid is relatively stable.
mm.
And same time they are introducing tempo. So
Okay.
together it is helping them to study these things. So it is giving some time for this
Mm,
equilibrium. So it won't
okay.
go under self coupling, and then they are analyzing the ratios based on this protecting group. So two things it is doing. One is that this,
Mm,
like after forming, like when it is going anomirization, these intermediates, first thing
mm,
it will stay as it is and it will give some time to study. And another
mm,
thing, it will resolve this problem of these things. Earlier, when we are doing normal mutarotation study in a
mm,
stick condition,
mm.
in that case it will go open form, but in this case it won't go under open chain.
Simple. Simple. Okay.
So that is the
Mm,
main key point from here. That is, I guess, only one point, and then other things they are indirectly somehow correlating.
okay. 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 Okay.
Like this,
Okay.
if
Thank
you
you.
see, this is not the experiment. They have just trying to
Yes, yes.
like
They showed for
correlate.
possible for confirmation.
Mm.
Yes. Okay. Thank you.
So it was little difficult, I guess. Maybe some of you might not have got everything. So it is
It is
just the
little tough to
presentation.
follow, but somehow
Yeah.
it is fine to on
Yes.
overall what is happening that kind of thing.
Because few experiments, sometime it is becoming why they are doing these things.
Yes. Yes.
So this is also old paper. This is 2012 paper.
Yes, yes, yes.
So just I took to see the
I used to cite this paper, but I never saw this paper completely. I just have seen the abstract dipole moment and the steric effect, whatever they told I have seen, but I haven't learned. That is good that got to see today.
So this studies is only for the tempo as a acceptor. So a radical reaction in case of tempo, not in other things like normal.
yes. So this is a kind of mechanistic investigation they have done. Not mechanistic, but yeah, kind of mechanistic. So this is specifically designed with tempo only. If you take the one another paper is there where they have shown the other radicals. So in those cases, the another problem of the self-coupling and polymerization is there. So tempo is the best. In case of tempo, you'll be getting enough time to study this equilibria, and you'll be getting this ratio persist like consistent ratio. You will get the alpha beta anomers.
I think they can't generalize this reaction because tempo in photochemistry it acts as a very good radical scavenger. So wherever the radical will form in the reaction mixture, the tempo will attack definitely. So maybe they can't
Yes,
generalize in the normal generalized reaction. In other radical
correct.
acceptors, maybe they use.
Yes.
Hmm.
So that's why this is very specific study there.
Nice presentation, Deepak. Uh, Starting with this slide only. So let's say they have taken here Xanthate type of donor.
Yes.
So main purpose to generate the radical of the Sialic donor,
Yes.
then quench with the tempo.
Yes.
So further, they did not carry out this reaction. They went with the thione chloride donor where they did not get the selectivity. So like ultimately they wanted to see like how this radical is forming and then how how it is getting quenched with the radical acceptor or something else.
So ultimately, they are trying to show the effects of this cyclic protecting group on the anomeric ratio of these sialocytes. So how these protecting groups are affecting the anomeric ratio of these glycosides. So that's why. So one initial thought, as I was telling earlier, so we can think of the first obvious choice will be that you take the corresponding hemiacetal and see the enumeration there, mutarotation, how the alpha beta ratio are distributed there in the case of hemiacetal. But in case of sialic acid containing this cyclic protecting group, this compound itself is not stable in
Step.
the acidic solution. So in that case, when they'll try to study the muta rotation, so already it has been worked out. So in that case, this form will be more open chain keto form will be more. So what they have thought, so they will utilize this tempo and radical condition instead of generating this compound. They will generate some radical intermediate, so that will be stable also, and that will give some time to study the anomeric ratio. So then they are changing these protecting groups and they are showing in the case of this particular reactions when this compound is there and when the corresponding sialocyte which is shown in the previous table. So when they are treating, they are taking the particular concentration and they are heating at 90 degrees Celsius, and in that case using NMR they are seeing the equilibrium is staying like this. So when this simple protecting cyclic protecting group is there, then they are getting the maximum alpha to beta ratio. But the moment the acetate group or this group is getting removed, similarly the selectivity is reducing for the alpha. So that latter they have tried to explain using the, so this is their proposal. So what they are proposing that is happening because of the dipole moments of the corresponding protecting groups.
That's fine. See, in the like slide number 3, here they have taken the xanthate donor. Now come to slide number 5.
Yes.
So since now here they have taken the thio and the chloride donor. So let's
Mm.
consider if they will take the this donor thio and the chloride. If they will take tempo only, so they will get the based on the protecting group or the based on the this radical acceptor.
Okay. So now I understood your point. So
Yes.
that is not donor, I guess. So I don't know how to explain that, but tempo is not the donor. So that they are just doing for the
Yes.
self-enumeration.
So
So
tempo
you are
till now
trying
that
to generate this radical and
radical,
now
yes, sir,
couple put
with the same
another
radical.
radical scavenger. So kind of.
Yes.
So maybe this itself is getting so. So right now I can think of that is not a donor kind of substrate. Like these are known to be donor. So this will couple with the uh,
Yes.
different radical acceptors.
These two can be activated by any other method, but whatever xanthate they are having, that can
Yes,
only activated by the radical pathway.
correct. Yes.
So that's what my confusion has. Like if they wanted to show the radical mechanism, this is the pathway is following, and the main factor is the dipole moment, and dipole
Mhm.
moment can be tuned or the manipulated by the protecting group.
Yes.
Later in that example, that is not even helping. Like so they went with
Here,
way of
yes, in this case, from this experiment, it is shown that this doesn't have any role. Like this protecting group has no significant role on this selectivity. Yes, correct.
so that's what like it's like since the tempo is very stable or persistent radical. So if they could have taken that, then they can claim something like okay, no, with the tempo it will work. In the case of 7, the alpha will be more. In the case of 9, the alpha will be like alpha beta ratio will be little higher.
Yeah, so I got your point. So only that I look into it. But at that moment, like if I remember from this paper, so why they have selected these things? So they have selected this thing to show the kinetic selectivity. So the in case of if kinetic product will form, in that case, this role like this protecting group influence is not there in the case of kinetic selectivity. So somehow they are telling that if so this system is designed to get the kinetic products. So if we are getting kinetic product in that case, will not get the selectivity.
Yes, got it, got it. Tempo will be the like
So that
stable.
is
Yeah.
undergoing kind of thermodynamic thing that is stable, but this is kinetic.
Yes, yes, yes. Now it makes sense. Slide number 4. So here you see the both
This,
of is carrying 4.6 dipole moment, and the oxazolidine one is the 5.07. So that means that has higher dipole moment, and it's not even
yes,
zero point 0.4 more.
yeah, yeah, correct.
So now come to
But
next slide.
this slide you are discussing.
Now if you see that okay, difference is very less only. It is come
Less
kind
only, but actually this I also saw.
of
So here they are taking this textbook example solely, but the moment already in other papers also in the particular sugars, already few more studies has been done. So when these both oxygens are there, in this kind of setup, it has the maximum dipole moment, like difference is there. So this is having more dipole moment than this. So if you'll see just dipole moment, so in this case it is maximum. In this sugars it is known.
and also whatever phosphate donor they have prepared here. So
Yes.
and they got beta with respect to phosphate.
Correct. So that is also one point. So in most of the cases, they will get this beta selectivity. In one of the cases, they got some little mixture, so that they have purified. Most of the time, they will get beta only maximum.
So
So that
even
they
though
are making from
with
thio.
the donor,
Hmm.
okay, so we can like one can say, let's say if someone will take the thio donor and they will get more like a beta. If someone will take the phosphate donor, uh, in that case they will get the kind of alpha product.
No, I didn't get what.
So see here they have taken the thio donor to make the phosphate donor.
Correct.
So with the thio donor, maximum time they are getting the beta, no matter what protecting group it is there at the C5 and either site
Yes.
open.
So it has something to do with this phosphate also. So I haven't explored much about this donors, but here something to do with this phosphate. The moment they will take this phosphate acceptors, in case of other donors also, this is also one kind of donor. So in that cases, there people are getting the this beta selectivity only. So there some significant role of this phosphate acceptor is also there. Right now, I don't know.
Yes,
So,
yes, yes. So like one more thing, just this is last question. So in the phosphate donor only, so consider this 19 and the 18 and 19. So now the C5 is carrying the oxygen.
yes.
So what it is? It is sialic acid only, or is a
Yes,
derivative of?
it is coming from the same family. So it is kind of, its name is that KDN, that keto means
Okay,
some, it is coming from the same family. So many people like it, it has some different role in biology. So sometimes people will use this KDN also and sialic acid also.
okay, it's not sialic acid then, no?
It's not neuraminic acid, but it is
Same.
sialic acid only. It is from the same family. So it's
Okay.
not completely different. So in biology, all these things are there. So it means nearby only, not very far.
Hmm.
It's not
Yes, yes.
exactly the neuraminic acid we are still like whatever we'll refer mostly in general sialic acid, that is an still neuraminic acid. But this
Yes.
is coming from the class of neuraminic acid only.
Okay.
So this is just not an acetyl. This will be the O neuraminic acid.
Okay, it's like same thing, just
Yes,
N style replaced with the
yes.
oxygen. Yes, okay.
Yes. So this is the very close relatives, like we are studying the glucosamine and glucose. It's
Glucose.
like that. It is the close relatives.
Yes, yes, just one change, nitrogen and the oxygen. Thank you.
Yeah, nice presentation. I have a two general query. It's like, what is this onset cone voltage? Like they are applying for
So,
specific reason.
so cone voltage is what like in our HRMS also, if you will see, cone voltage is defined as the voltage. It is required to uh, like we have studied right that particular voltage that ion will go into the this charged tunnel, so that only it will hit the like detector.
They
So
can
that
select
but
only some specific part for the whole molecule. They are going to mean
like whatever we are like if you'll see our HRMS facility, so that comes under the moderate, like there also some defined voltage is there, so that will give the M plus peak or M plus N molecular ion peak if you have to get. So you'll give the minimum voltage. So it won't create fragmentation. It will take your full molecule. But if you'll increase the voltage, depending on these energies of various bonds, it will create the fragmentation.
I
So
thought that
that
like cone is there, so they are making cone, and in that region only that molecule is going to affect.
Yes,
What I
correct. So for these, whatever we are seeing here, they have optimized it separately. They have done at the various voltage, and from there they have selected these of interest. Like for this molecule to get these two intermediates selectively, you have to excite at this voltage.
okay, okay. And the second is that like about dipole moment.
Yes,
Like there are two procedures like experimental and theoretical. So like this in slide 5,
yes.
like for any sugar molecule or sialic acid, any complex molecule, if anyone want to calculate this dipole moment, so is DFT is going to help or some other procedure?
That is good question. I also have to check, but mostly I guess these are the experimental results. So sugar also, I guess maximum experimental result will be the only final thing. DFT can predict, I guess. I don't know.
Like this
But
simple molecule, this cyclic and acyclic, uh,
yes,
but for like complex molecule, like in sugar molecule, so in that molecule, how anyone can calculate this dipole moment?
yes. So that we'll see. I'll check. Right now, I haven't thought of it earlier.
Okay, okay, okay. Thank you.
Good presentation, Bhaiya.
Yes,
My question in radical form and oxocarbenium anion. This
yes,
structure is different. Okay,
yes.
means like 4C1 or 4C1. What is this? So what this structure also effect na it in radical form is different and carbocation form is different. So how to correlate this radical mechanism with oxocarbenium mechanism?
So what they are saying here, so they are keeping it close. Like in this case, when they are, sorry, when they are getting, like when they are not obtaining the selectivity. So what they are thinking, so in this particular case, the radical intermediate is very much close to the this hexacarbenium ion intermediate only. It is similar to that. So that's what they are proposing. Maybe it is like this only, and again it will be planar. So if it is planar, so most likely it may not be staying as it is. It may be undergoing this half chair conformation, and there they are explaining that since in these planar forms, none of the phase are getting too much sterically blocked, so both possibilities are equally facile to undergo beta phase attack or alpha phase attack. So that here they are showing this the intermediate forms here like radical most likely, so it will be closer to this hexacarbenium ion only, similar to this only, and that's why they are getting the 1:1 selectivity.
Okay.
So that could be the reason. So still maybe further papers will be there where people have studied the actual conformations of this carbocations and radical. Since this is old paper, that time they have tried to show the, like based on the result they are inferring it could be, this could be the pathway. That's why they are getting the uh, means they are not getting the stereo selective product.
Okay. And second thing, there is a chain is there at going salicylic acid structure. This another chain is there at fifth position. So it will also help in the this selectivity.
Correct. So it also has, that is the reason, like again the whatever you are telling the confirmation, for that time for those things separate studies are there. So this will like it will block. So again based on the confirmation it will block some of the surface, sometime this beta phase or sometime alpha phase. So based on it has some, definitely it has role in the selectivity, but in different conditions when the protecting groups are different, so how it is getting oriented, it has some significance is always there.
Yeah. Because I read this paper, one paper is there in septenoside furanose form. So in this
Okay.
case also this chain is formed, na? So it is
Yes.
very less going to mutar rotation. So in that case also some mutar rotation if like happen, so it is compared to glucose is less or more fast.
Mutar rotation, that's what they are saying in the case of these traditional intermediates. If you'll take this kind of intermediate, so mutar rotation is, I don't know, mutar rotation is not the moment it will go to this open chain form, the likelihood to come in this cyclic form is very less. So it will stay in the open chain form only.
Open chain only. Okay.
Yes.
Okay, Via. Thank you.
If you enjoyed this session, don't forget to like, share and subscribe. We'll meet you in the next episode, next session. Thanks for watching.